Good morning. Let's do another Leetcode question today. I'll be acting as a mock interview candidate, and we'll be choosing an easy algorithms question, and we'll start the timer at the top as well. So not this question. Hope you guys are having, and not that question either. All right, here we go. So we have a new one. It's called Contains Duplicates 2. And if you guys have watched my videos before, you'll notice that I'm using the Leetcode editor instead of a GDoc. And I'm pretty happy to do that because now we don't have to deal with all the tabbing issues and things like that. So what I'll do is I'll start the timer, and we're going to try to see if we can solve this problem. And I'll try to act out kind of the questions and things I would want to do as a candidate if I were interviewing myself. So take it as you will. And if you're interested, I'll have the link below, and you can follow along. And if you see anything I don't, feel free to let me know in the comments. I miss a lot of things, as you've seen in my other videos, but as long as you can convey what you're thinking pretty clearly, that's, I think, more important than just like banging out the right answer without any communication. Okay, we're given an integer array of numbers and an integer k. Return true if there are two distinct indices I and j in the array such that the array of I and array of j, nums of I and j, and are equal to each other, and the absolute value of the distance between those two indices. The distance between those two indices is less than or equal to k. Okay, so it has to be a duplicate within a certain range. That's kind of fun. So we're not just looking for duplicates, we're looking for whether those duplicates are within a certain range. And the question I kind of have when I first hear this are, what if there's multiple duplicates? Does that matter? It doesn't seem to matter. In fact, they might even say in the constraints that there's only ever one, but it doesn't look like they say that. I think it's as long as there's at least one such duplicate, you're good to go. Okay. Then the second question I might have is, how big is this array going to be? Could it be empty? Could it not fit in memory? Since this is Leetcode, the answer is going to be it's going to at least be one value, and it'll be at most something very small under the length of a memory. 100,000, I think that is. And the values of the numbers, another question is, are they all going to be valid? Leetcode, again, the answer is always yes. If they weren't, you just want to add some checks inside your code, like, raise an exception if the values are invalid or whatever the interviewer asks for. This is kind of where you can raise questions for how you'd write this code. Another question is then, what about k? How big could that be? What if k is 0? Then the answer is always going to be false. What if k was negative? How do we want to handle that? It looks like here negative k would just be always failing because you can never have a distance less than 0. Yeah. Okay, and the output's going to be a boolean, inputs this array of integers. And here, in fact, we see that k is always at least 0, but if it's 0, we know the answer is false because it would have to be two distinct integers. So one quick thing we could just start off with is, if k equals 0, I return false. If the indices are right next to each other, then it'd be a 1, and that could happen. So how do we want to go about solving this? There's a couple of ways we could do this. One is kind of the brute force approach. Let's create some notes right here, and you guys can still see everything? Yeah, cool. So one idea might be, how do we want to write this? Approach 1. I say brute force pair compare. Compare every pair of integers. Since there's n integers, there'd be n times n comparisons, or O of n squared for time. The nice thing there is the space complexity is 0. And the checks could just be as simple as, for every possible pair, you do something like do the check for I, j in all pairs. And I'm just writing pseudocode here. And we could just do if nums of I equals nums of j, and absolute of I minus j. I mean, it's literally as they wrote it, return true. And then at the end, we return false. Otherwise, because we didn't find any pair. That's one possible approach. In fact, this would just go right in like this if we wanted to. And you could do this. Well, not like that, but it would be a double for loop. But we're not going to do that just because that's a bit too straightforward and takes too long. And O(n) squared is usually 2 brute force. So let's start thinking about some other approaches. Approach 2. What we've done before, I think we've had a contains duplicate question, and the idea is to use a hash map or a dictionary in Python, which is a hash map, and store every unique value and point to index. And if you ever see a collision, then we just return. So we can actually do the same thing here. I think we just keep the two indices, and we have the special check of not just if they're the same, but also if the absolute value of the distance is the same. The nice thing about this one is it's O of n time, because we're only doing one, maybe two passes, actually just one pass through the array. However, we are now storing a hash map of all the values, and in the worst case, that could be every single one. So O of n space. Which, depending on what the interviewer wants or doesn't want, you have to decide. You can kind of like bring up the option to them. Do they care more about space or time efficiency? And sometimes the first approach might be better, like say on a very small machine that has no, like a microcontroller that has no memory or a large array, and it's just getting in log values coming in over time or something like that. Are there any other approaches? Let's give this one a name. Dict approach and brute force approach. There probably are. I'm trying to think. You could sort the array. I don't think we're going to actually do this. Approach 3, sort. And the idea is sort the array and sort the indices to keep track of original indices. And then you can iterate through the sorted array, checking for duplicate values. And if so, good to go. So the same logic would apply there. We'd have O of, let's say quick sort is the most common one used. O of n log n for sorting in time, and then a O of n pass through the array afterwards. You could do an in-place sort, so it would be, well, no you couldn't, because you have to keep track of the indices as well. A second, just got a text. Oh, never mind, nothing important. Okay, so that's fine. There might be arguments for this one as well. I think it doesn't make much sense here because O of n log n is not as good as O of n. So let's assume for the case of Leetcode, we're going to choose approach 2. We've agreed with our interviewer that approach 2 is the one we'd like to do. So let's have a go at it. And we're about 7 minutes in. That's totally fine. You can do this faster, especially if this is a screening interview. I'm just going over every option here for the video, just so you guys can follow along. Feel free to skip around as you need. You don't need to go into as much depth about all the approaches. You can say one sentence for each. Like I can think of the brute force approach where you do every pair compare. Then you could say I can also see doing some sort of hash map approach, which would be O of n time. Maybe there's another option of a sorted, and that would be O n log n time. Maybe less space. These are the kind of things you can just kind of talk out loud with your interviewer if that's what they're looking for. So approach 2, build a dict of, let's call it values. It'll be dict of value to indice, like that. And then we can just do a check while we're going through it. So for I, that'll be our index, and value, let's call it, and enumerate, and that gets our index for the array as well as the values itself. We'll create our dictionary right here, and we'll call this D. Sorry, I was trying to think of something more clever than that, but no need to waste our time on that. So let's see. If the value is inside dictionary, and let's just put some parentheses around everything to keep everything clear. And the dictionary of value is, so actually, one of the things that comes to mind now is what happens. Let's kind of do a test case here. Let's say we had 1, 3, values of 1, 3, 8, 9, 4, 3, 6, something like that. Or let's see, 8, 3 again, 2, 3. And what I'm trying to get at here and say our k is equal to 2. So we know that this 3 here and this 3 here are within 2 of each other, but because we have the 3 in the beginning, we're going to populate our dictionary with that value. So d of 3 is going to equal to index 1 initially as we go through the array. And then when it reaches this 3, 0, 1, 2, 3, 4, 5. So d of 5 at index 5, we see that d of 3 is equal to 1, and index 5 minus 1 is greater than 2. So fail here. But once we reach the next index at index 5, 6, 7, we haven't updated our D3 just yet. So maybe what we need to do is actually store a set of all possible indices where it might be. I think that's what we're going to end up doing. Because what we'd like to do is at index 7, we check our D of 3 and we see that there's a set of 1 and add set to set index of 1 and 5. And for each one, actually, instead of a set, we could just do a list since we're going to iterate through it anyway. And there shouldn't be any repeats regardless because we're iterating through this array and there's only one index for each value in the array. So clean that up. And 5, so 7 minus 5 equals 2, so success. Yeah, so that's how we'll do the checks in there. And I'm interested to see if that'll change our O of n. In the worst case, no, there's still only n compares. I guess the worst case could be that all of them are 1s. So let's just think about that for a second. So 1, 2, 3, 4, 5. And say k equals 5, you know, the worst case. So our dictionary is going to end up being d of 1 equals 1, 1, 2, 4, index 0, 1, 2, 3, 4, you know, like that. So our dictionary size is still going to be O of n. That's not going to change. Our check's going to be up to O of n squared, I think, in that case. No, it wouldn't be, because, well, it might be. Sorry, we're kind of getting into the weeds. O of n squared time. That's kind of what I'm trying to start thinking about right now. Because I don't want to go through all the effort of writing this code and we realize we've got a pretty inefficient time solution. Is it true that we would have O of n squared time? Because every time you check, you're adding to that first dictionary location. Yeah, it would be. So I don't think I like this. Let me know in the comments if I was wrong about this O of n squared. What I'm starting to realize is, so yeah, what I'm starting to realize is we don't need to keep a dictionary of all the values. We only need to keep a dictionary in a sliding window of k. And that's one way we can keep the dictionary from ever growing too big. How do we do that? I think the idea is if our current index if here the distance to that is greater than, actually I think we can just replace the values whenever it's too far away. Yeah. And that gets us back to O of n time. So instead of keeping a list, so if the distance to a previous existing dictionary entry for the same value is greater than k, then it's never going to work, and we can replace the value if it's the same one. Yeah, and that way we get back to our O of n time. So in fact, we can keep using this, and that makes things a little simpler. So if the value is in D, we'll actually just keep this as a separate if statement. We can optimize this later. Let's pull this back down. You guys can still see? Cool. Okay, so if the value is in D, and now if the if d of value, that's j, so j equals d of value. If absolute I minus j is greater than k, replace that d of value equals the current I. Too far, replace. Else it's within range. And we're already doing the if the values are the same. This is basically doing like a nums of I, nums of j. So we can actually do it the other way around just to keep everything the same. Return d of val, and do they care about the order we return everything in? It's actually just true or false. True. Otherwise, too far and replace. So if the value is not in the dictionary yet, we add it. And I'm trying to see if we can actually combine these two into one statement, because here we actually can, because if it's either too far away or it doesn't exist yet. And either of those cases, we are replacing it. So we just return true. Return true, return false. And I think that's kind of how we simplify this down. So what we're doing is we're checking if value indict and distance of indices less than equal to k, return true. Otherwise, too far can replace if exists, or can create or replace if exists. Nope, saved local. I have my default like muscle memory to press Control S. Okay, I think this makes sense. So let's just think about this for a second. We're returning a bool true if these cases are ever the case and false otherwise. We're building up this dictionary as we go whenever the value is not there. And we're checking to make sure that the value exists already, and we're putting in the indice of that one. And we're not even caring about what those indices are. We're just returning true or false. Okay, I think that's about it. So let's just have a go and see how it goes with the test cases. See if I'm missing any logic, but looks to be good. Passes the test cases. One I might think about is, what if the array is empty? Are we allowed that? No. But if it were empty, this for loop would never happen. We just return false. So that might be a valid answer. It depends on what the interviewer wants. Let's submit and see how it does. Yay, always good to see when it runs the first time without any issues. Feeling good about this one. I wouldn't worry too much about the speed, though actually this is a pretty large range, so I'm interested to see what might be going on with some of the other approaches. Usually the variation on the order of 20 to 30 milliseconds has to do with the back end of the Leetcode rather than any algorithmic complexity. There might be some other shortcuts where you use something that has a C backend for like for loops and stuff like that. But I wouldn't worry too much about that as long as the main logic is clear. Trying to think if there's anything we could do here that would make this a little bit more elegant or readable. I think if I were writing this code for a real code base, this D label would probably get turned into something more useful. Repeats, perhaps. And let's make sure we do it everywhere. We're trying to make sure that the label's in there. This is all just kind of documentation stuff. This isn't usually a big deal in a technical interview. I'm just a bit excited to get it optimized there. Trying to think of anything else. we might be able to return true. We might be able to turn this into a one-liner, but I don't really see if that's elegant or not. We know this is going to be, at the end of all this, O of n time and O of n space. It was nice that we were able to realize that we can replace the value if it's too far away, because that makes things a lot easier. And I'm glad we spent time thinking about that, because I think if you had tried to go with this list approach, it would have worked. It would have been more complicated, right? But at the end of the day, the issue is in the worst case, when you have, say, all the exact same value, it becomes O of n squared, because as you keep going along the list, you're checking that one value with all of the previous values, and that by definition is a more optimized brute force of O n squared. Glad we didn't have to do that here. And if that had happened, then the other approaches would have been roughly, well, actually the sort approach would have been better. Cool. All right. Well, I hope this was interesting to all of you, and it looked like we did in about 18 minutes. Had a great time, and see you guys next time.